Part 2 takes us to a completely different timescale. Parts 1 and 2 were about big decisions, how much to practice and how to schedule whole sessions across days and weeks. Now we zoom all the way in, to the gap between one individual trial and the next. The question sounds simple. How much rest should there be between reps? But it has the most interesting answer in the chapter, because unlike the clean session answer from Part 2, it isn't one size fits all. It depends on the kind of skill you're practicing, and it took the field decades of tangled, contradictory research to work that out. Let's define the question precisely, and then trace how that controversy finally got resolved.
So let's define the intertrial interval precisely. We're zooming in from the macro question of how to schedule days and weeks down to the micro question of how much rest to put between individual practice trials. By far the most research on practice distribution has actually been on this question, and I have to refine our definitions for this smaller timescale. Here, massed practice means the rest between trials is very short or non-existent. Practice is essentially continuous, one rep right after another. Distributed practice means the rest between trials is relatively long, often as long as the trial itself, or longer. Same two words, but now they describe the seconds between reps rather than the days between sessions. You might reasonably expect the answer to match Part 2. Distribute it, wins, give it room to breathe. But this is exactly why we kept the two questions separate. The intertrial story is genuinely messier. It generated decades of scientific controversy, and the resolution turns out to depend on something we haven't considered yet: the type of skill. Let me tell you about the controversy first, because how it got resolved is itself a good lesson in reading research.
For decades, the research on intertrial massed versus distributed practice was a genuine mess of contradictory findings. Some studies said distributed was better, some said it made no difference, and the textbooks and reviews disagreed with each other. When a literature is that tangled, it's usually because of a flaw in how the questions were asked, and here there were two. The first flaw is one we've hammered all semester. Many of these experiments measured only performance during practice, with no retention or transfer test afterward. So they were measuring temporary practice performance, not learning. And as we know, those two can point in opposite directions. The second flaw is that researchers generally failed to consider that the two schedules might affect different types of skills differently. They treated motor skills as one undifferentiated category. The resolution came from meta-analyses, big statistical reviews pooling many studies by Lee and Genovese and by Donovan and Radosevich. And their key insight was exactly that second point. The type of task is the decisive variable. Whether massed or distributed intertrial practice is better isn't a universal fact about all motor skills. It depends on what kind of skill you're learning. Specifically, it hinges on whether the skill is continuous or discrete, and the two go in opposite directions, which is the next slide.
Here's the resolution, and it's a satisfying one because the answer flips with the type of skill. For continuous skills, skills with no clear beginning or end, like the classic rotary pursuit task where you try to keep a stylus on a spot on a spinning turntable, distributed practice with longer rest between trials produces better learning. Continuous skills have been the most studied case here, partly because it's easy to set up clearly massed versus clearly distributed intervals. A trial might be 20 or 30 seconds, and you can make the rest essentially 0 for massed, or just as long for distributed, so the two conditions are unmistakably different. And the consistent result is that distributed wins for continuous skills. But for discrete skills, skills with a definite start and finish that are over very quickly, like a single rapid aiming movement, the opposite holds. Massed practice, with little or no rest between trials, produces better learning. There's a wrinkle worth knowing. With a discrete skill that lasts, say, 150 milliseconds, a distributed rest of the same length barely differs from massed, so the two conditions are hard to tell apart, and very few studies have managed it cleanly. But what evidence exists points to massed being better for discrete skills. So the rule to carry: distribute the trials for continuous skills, mass them for discrete ones. Let me close the chapter by turning all of this into practice.
Let me make all of this actionable, because the textbook offers a lovely way to combine today's distribution principles with the contextual interference idea from last chapter.
The unifying move is to break practice into spaced, interleaved chunks rather than long single blocks, which simultaneously distributes the practice and raises contextual interference. 3 settings. In a PE class with several drills planned, use a station approach. Assign each drill to a spot in the gym, divide the class into groups, keep each group at a station about 12 to 15 minutes, then rotate. And if the period is long enough, rotate through more than once. In a sports practice that includes several activities, instead of spending one long stretch on each, cut each activity's time in half and run it as 2 separate sets across the session, scheduled randomly or serially. And in a rehab session, do exactly the same. Take each planned activity, split its time in half, and deliver it as 2 spaced sets rather than one long bout. In every case, you get the double benefit. Practice is distributed in time for better consolidation and less fatigue, and it's interleaved for the contextual interference advantage. Distribution and variability, working together in one simple scheduling habit.
The last part, part 3. The intertrial interval is the rest between individual trials. And here, massed means little or no rest. Distributed means relatively long rest, a different timescale from the session question of part 2. The research on it was controversial for decades, for 2 reasons. Many studies never gave a retention test, so they confused performance with learning, and they ignored that the effect depends on skill type. The resolution from the meta-analyses is that task type decides. Continuous skills learn better with distributed trials, discrete skills learn better with mass trials. And practically, you can fold all of this together. Space your sessions, and chunk practice into interleaved sets that combine distribution with contextual interference. Keep that pairing in mind as we close the chapter.
To bring the whole chapter together, the next 3 sheets translate the science into one profession each, so you can see these scheduling decisions in the clothes of a real job. This first one is for occupational and physical therapists. Notice how it reframes the chapter for the clinic. A sensible amount of practice and overlearning to lock in retention, but an eye on diminishing returns since therapy time is capped. Favoring more frequent, shorter sessions over a few marathon ones to leave room for consolidation. And combining distribution with contextual interference by running activities as spaced sets. The motor learning principles don't change, only the setting does.
This second sheet is the coaching version, the same science applied to managing a team's practice time. Look at how it lands the big ideas for a coach. Use overlearning to make skills permanent for game day, but don't waste the limited season on reps past the point of diminishing returns. Schedule more frequent, shorter practices rather than a few exhausting ones. And break each activity into spaced sets across the session, so practice is both distributed and varied. And the recurring warning is here too. What feels like efficient, productive cramming often teaches less than spaced practice that feels slower.
And the third sheet is for movement instructors more broadly, PE teachers, dance and skill instructors. It pulls together the chapter's whole arc. Figure out how much practice a skill really needs, rather than assuming more is always better. Plan units as more frequent and shorter sessions instead of a few long ones. Use station rotations to distribute and interleave practice, and match the intertrial spacing to the skill, distributed for continuous skills, massed for quick, discrete ones. 3 professions, 1 science. Which brings us to the takeaways. Let me land us with the 3 things to carry out of this room. First, more isn't free. A little overlearning genuinely helps retention, especially for procedural skills you won't perform for weeks. But extra practice hits diminishing returns fast, and pushed too far, it can actually hurt your performance on the real test through boredom and over-drilling. And amount never acts alone. It only matters in interaction with everything else. Second, space it out. The same total practice spread across more and shorter sessions beats cramming it into fewer long ones, because spacing means less fatigue, more genuine effort per trial, and time between days for the memory to consolidate. What feels efficient about massing practice is an illusion. And third, let the skill decide the spacing. For the rest between individual trials, distribute the trials for continuous skills and mass them for discrete ones, and weave in the contextual interference from last chapter so your spaced practice stays varied. The master principle tying it all together is this. Under real-world time limits, you win not by adding more practice, but by spacing and organizing the practice you have.
Make every hour count. Thanks, everyone. Go build practice schedules that breathe, and I'll see you next time.